Let's see. Microphone is on. Video is on. I am on, I think. Okay, so let's see if I can find my video and share it on Facebook. Maybe some people are already at home, or maybe they are bored at work and want to see this video. So let's give them something then. Yeah, it's live. I'm live. I can see myself. Let's share the stream on Facebook and all the other channels. Oh, I'm logged out. Why am I logged out? I don't know. Let's log in. Oh, I know why I'm logged out. I had to clear all my cookies because I had some problems on one side. And they told me to clear all my cookies, so I did. I'm so obedient. Anyway, my timeline. So, live assembly of the first Spectranet. Share. Share. Twitter. Oh, no, I don't want to sell something. Come on. Oh, the buttons move on the page. I hate it when it happens. When the page is loading, the buttons move. Oh man, so ridiculous. Don't do that. Twitter login. Okay. Am I logged in here correctly? Yes, I am. Otherwise, I couldn't post in these groups, I guess. And this one, Spectranet. We love Spectranet. Okay, and okay. And yes, it's on Twitter as well, because it automatically posts on Twitter when I put something on my timeline. Which is great. You wish. Sorry, I'm distracted by something on Twitter. But it's unimportant, completely unimportant. Oh my god, there are some people already in the stream. Jan, goedemiddag. Tom, of course. There's no chance you wouldn't be here. Hugo, good afternoon. Yeah, Darren, good afternoon, man. 6 people already. I'm just starting. I'm just getting started. But I've got some stuff on my desk already. I can show you. Just have to click on. Oh, I forgot something. I have to do some slide configuration here. And can I do that right now, or shouldn't I do that? We'll just use the mouse then. I can use these buttons here, but for now the mouse would be better, I think. Look at that board there. You can always send me your money if you want to. But if you want some products in return, then maybe you should wait. Anyway, I'm a bit far away in the small screen, but this is the most important here. This is what you want to see. Hey, Louis, good afternoon. Hey, Tex, good afternoon. What Spectranet is? Well, Spectranet is the one and only Ethernet interface for the ZX Spectrum, which already got some base when you're talking about software and support, whereas the Wi-Fi add-on for the ZX Spectrum Net is brand new and doesn't have much support at all at the moment. That's what I think, at least. And maybe that will change, and I hope it will support the features that the Spectranet supports. So we got here the Spectranet board. Let's see if the camera wants to cooperate this time. Yeah, it does. So this is it, and you can see there are quite a lot of... come on, focus, man, focus. Yeah, thank you. Quite... It's so ridiculous. It doesn't want to end. Let's put it closer maybe then. Yeah, here it is. No, keep focus, you. Right, so you see some SMD chips here, quite a lot. Dylan selected some parts that are kind of hard to obtain and in the correct package, but I got some of them. Stop focusing, damn camera. Anyway, let's put it here. So we have a couple of parts that may be a little hard to solder, but Maybe not, because I've soldered them before, like this 100 pin CPLD chip here. Got plenty of them. Maybe I should put on the bill of materials, because I should make it certain that I pick the correct parts when soldering them on. Of course, you're welcome to make a manual, but of course I must make a manual myself anyway. Maybe we can join forces here. Let's see, it's an Ethernet interface, blah blah blah. I believe that a certain person who's not me, NXTL, oh, okay, cool, very cool, Play-Doh, oh yeah. Would that person be Robin? Okay, well, let's go on with the chat. I'm afraid I cannot keep up, because I want to focus on the dang interface itself. I've got some files here. Maybe it's good to just have the bill of materials, which I edited myself. Is that something I can read here? I think so. Overall, I made a bill of materials in an overall document here. Oh, it's long, man. Okay, let's make this a... What is this? Right? Let's make this a table so I can read it more easily. Yep. Yep. Alright, that's better. But it's still very small. But maybe I can read this. It's a long list. There's so many parts on the small PCB. It's a 4-layer board, by the way. I haven't checked if it's actually 4 layers, but I'm not sure if I can easily see that now. You cannot see it easily. Anyway, let's print this document, because it would be very useful. Small margins, 1 by 1 page. And let's see what happens when I want to print this. Okay. Right. Oh, so many messages, guys. I cannot keep up here. Good evening. It's not evening here. What time is it, 8-Bit Dreams? At your location. Go solder. Well, I will get to work, but I must take my time, to be honest, because I don't want to make mistakes and spend more time than I should. And I actually don't have that much time, because we're always having dinner early in the evening, and I want to be able to do that with the family. But okay, here we have the bill of materials. Oh, whoa, sorry for the camera movement. It's getting a bit dark, but that's because of the weather outside. The camera is making me mad. It's trying to focus continuously. So now I'm going to shut the focus down. Yeah. No, yes, this is the correct one. Advanced, and automatic focus is turned off. So now I can do it manually. So I can annoy myself if I want to. But that's not what we want. Is that right? Right. I'm from Germany. Okay, cool, of course. But it's not even there just yet. Oh yeah, okay, of course. You ordered the Plus Delight. Well, actually, I sold 2 to Syntec last week, and I have to produce 5 more. So I can show you. I'm not lying. It will not take that much time, but I haven't come to it today. So here I have the Plus Delight case with all the parts for 5 more boards, as you can see. So won't take that much time, but one more day, I think, I'm afraid. Anyway, let's get back to the Spectranet, of course. So this is my Spectranet back crate with lots of specific Spectranet parts in here, because I haven't had the time to put them all in my blue cabinets, in these ones, and I might not have enough space in those cabinets, but we'll see later on. Okay. When I assemble new boards, I always make a list of the order that I will assemble it in the future, and that is what I call a build guide, which you can see here for all the other boards. I'm still coping with hay fever. It will take another 3 or 4 weeks. It's not that bad because of the rain today, but it's still messing with me quite a bit. So again, when I do a new board, I always create a build guide. So I will do the same this time. I will just need a small piece of paper, which I call Spectranet build guide. And now the pencil's not helping me. Okay, guide. So, as always, I will start with the smallest SMD parts, the discrete parts actually. Put it to the side. And there are quite a lot here, and it's not easy to find which one are which. And the bad thing, if you can call it bad, is that Dylan chose to use 0603 SMD parts, which are smaller than the smallest one I usually use. So it will not be the biggest problem because I can handle these. I'll put the soldering iron on. These are a bit smaller than what I'm used to, and it's hard to find the correct parts on the board because only the parts labels are on there. For example, the resistors say R1, R2, and so on, but not the actual values. So when I'm doing a board for myself, I can show you. This is an old one. I don't need that one. I actually use I put the values on the board. It's hard to see here. You cannot see it. Let me focus manually then. Come on, mouse. Right, so you can see that all the values of the parts are printed. So that's a lot easier when you're doing manual assembly of the board. Right. Well, I think, Tom, I have to learn from you to get used to the Spectranet. So that's because I haven't used one before, as I may have told you. What I'm thinking is, would it be easy to just make a layout and write down all the values, but I don't think that will be very useful because I have another interface that is not my own design. Which has the same, it's only labels and other values of the components on the board printed, and I have to use the build guide as well. So I just will follow the build guide. Let's just do that. And for example, I have 8 1 kilo ohm resistors, and the labels are in front of those. So maybe let's just start with those. Let's find the correct part here. Just put out all the parts that I need in a moment. So starting with the discrete parts here. Hey, Peter. 1 mega ohm, I guess. Oh, let's see. Oh no, that's a resistor. 1 mega ohm. Oh yeah, of course. I need 1 mega ohm. 1 mega ohm. This is 300 ohms. This is 68 ohms. This is a gauge. It's not a resistor, and this. I hope this is the 1K. Yes, this is the 1K in. No, it's not correct. I didn't order. That's odd. It says 0805. Did I order 0805? Did I make a mistake? Make a mistake with ordering these parts? I guess I made a mistake, but maybe this will fit. So I guess I think I just ordered 0805 types for all the parts and didn't notice that this board needs 0603, but maybe I did it on purpose because this might actually just fit. I think I checked it. So let's check it again. Cannot believe I made such a mistake because all the information is here on the bill of materials. So let's see if the 0805 parts will just fit on 0603. I think it will be no problem at all, especially when you're using a solder paste, a stencil with solder paste, then it won't be a problem at all. It's just a slight different dimension of the part. Okay, I need 8 of these. Come on, get out. 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this may seem a bit small, but I'm used to this because I do lots of boards like this manually. Of course, I want the pick and place machine to take over very soon. But maybe with the Spectranet, I will just continue doing these manually because I don't expect to make dozens of these. It's quite a specific product. So I'm pre-soldering the pins here. This won't be easy because for some components, for example, Dylan chose to just put some parts parallel, which also means that, oh, this is so hard, where's my braid? No. That some pads are just connected together, so it will be a bit tougher soldering them manually. Sorry for that. We'll get some water in a minute. Let's do it this way then. So I'm pre-soldering all the pins now before starting. Not that many, but if I would design this board to assemble manually, then I would do make some changes. But Dylan always had these interfaces made by some company, company that will assemble the boards for you. But I checked here in Holland, it's way too expensive to do that for small batches. And of course, Dylan just counted the price of that, the cost of that, into the price of the product. But I try to make the boards available for everyone, so not too expensive. And of course, doing this manually takes time, so that has to be calculated in the price as well. But anyway, let's get on. So R1, it's the first one. Where's R1? I've never done this board before, so I'm just going to start with it. And I can tell you that the parts are too big. So this is the first board, and I will just get the correct parts for the other boards. Anyway, R3, that's the one here. This is not the best solution, but anyway, for now, for a first prototype board, it wouldn't be that big of a problem. And Tom might be a bit scared now because I told him that I want to send the prototype to him. Or it's actually not a prototype, it's just the first example of the board. R4, where's R4? But don't worry, Tom, we will test this board out, and if there's any problem, we'll solve it. It's just that it has slightly bigger parts than actually the board should have. Okay, R13, where's that one? So many parts in such a small space. R13, 13, I can see 14, but I need 13. Oh, it's there. Maybe this looks a bit slow, but it's because it's the first one. If I do this daily with many other boards, then we'll go a lot quicker. 14, 15, 16 and 17, all 1K. I think this will work just fine. If you ask me, then I think it won't be that big of an issue using 0805 parts for the first board, of course. 17, where is that one? R17, I see C17, but that's not a part. R17, where are you? Where R17 you? R2, it's raining again. R2, R7, R11, where's, oh there's R17, okay, it's for one of the LEDs. Alright, okay, so we'll make a note that I put on those, and then I need a 1 mega ohm. You haven't even opened bags, I'm bad. And as you can see, I'm not sitting still. I got so many work at the moment that it's really hard still to decide what to do first. And even with, for example, the order of the Plus Delight, should have had a stock of them, and I try to keep up with the stock, but it's really hard to do everything all together at the same time. R6, where's that one? R6, ooh, there's R6, and I think it is oriented this way, I guess. Hard to see, but alright. And I think I have to measure because it seems that those two parts are connected, and I want to check it out before soldering the parts so close to each other that I cannot tell anymore. Okay, those pads are connected, that's what I wanted to know. Let's just put it there. Then the next part is R12 is a 12K. Do I have 12Ks here? Do I have 12K here maybe? I need 12K. Why do I not have 12K? 12K. I haven't seen 12K yet. What is this? This is just crystal. Why can I see 12K resistors? I thought I bought everything, but I don't see any 12Ks here. I wonder why not. I don't have them in stock. I only have 10K, but no 12K. Okay, that's another issue. 12K 1%. I don't have it. I thought I had everything in stock, but okay. Apparently not. Is the part mandatory? I don't know. I have no idea. R12. I can see R12 here, but I don't have it. So, okay, we'll leave it open and we'll just order more parts. So this will be quite of a part one of the board assembly. It will not be finished today. You can tell. So I'm soldering the other sides of the resistors here. They're so small, and the pads are so small that if you touch them, they move because the whole resistor gets heated. I'm trying to avoid that, but no. Well, when it says 12K 1%, I will not use a 10K because it seems that that value is quite specific. I know what you mean, but it's hard to tell what it is for. So I will just wait and get the correct part. It will only take a day or two or something. Hey Steve, good afternoon. Oh, Tom, in that case, I really need a second plug and place machine for 0603 parts. If you're going to advertise this board, and I guess people will love it, but the use of it has to get started. It's with all new interfaces, and this is no exception. So I will put a question mark with R12, and then we'll go on with 49.9 ohms, 1% as well, because it's apparently such a specific value. Ah, come on. This is stupid. Why did I buy the wrong ones? Because all the part numbers are actually here on the bill of materials, so I have no idea where I ordered the wrong ones. Anyway, I was just stupid. I think I just thought I needed 805 parts, so my bad. We'll get the correct ones this evening, and then we'll take 1 or 2 days before they arrive. That's just what can happen. Alright, R7, R8, R9, and R10. Oh, sorry, 11. So let's start with R7. Where is that one? R7, R7, R7. Where is R7? I can see R2, R6, R11. That's one we need as well. And I can see R8 and R7 there. Alright. Okay. Oh! There goes one. It doesn't happen that often, but I'm just doing too many things at once. So now I lost two. And I said that doesn't happen that often, and then another one jumps away. Where did they go? Oh, here's one. Where's the other one? I think I actually lost one now, but I have plenty of those, so that's not an issue. Where's the other one? Where did the other one go? Oh, there it is. It doesn't happen that often. Believe me, guys. I do a lot of these. And these are not the smallest parts. You can imagine if you use smaller parts like 0603 or 0402, which are only half of the size of these ones, then it will be quite hard. So R9 and R11. R11 I have seen, but R9, oh, there it is. Okay, R9. The parts are so close to each other, so I've learned from experience that when designing boards like these, and you want to do them manually, then create some distance between the parts and so. But anyway, it's even a 4-layer board. Maybe it doesn't have to be, because the board is quite small, which is good, but it's not really necessary. I think it would be okay if the board was a bit bigger. But anyway, this is what the Spectranet is known by at the moment, and I won't make any changes because it will take a lot of extra time. Maybe I will once if there's enough demand. We'll see. I'm not sure yet. Okay, a 300 ohm cell. So every mistake I've made when ordering the parts will be clear doing this video, because I will. I'm just unpacking all the parts right now. Didn't have time for it before. I wish I had. There are so many cool things coming in. I'm not sure if Jan Cusero will join the stream, but I just received this board here. This is the Embryo 3 Ultimate, Embryo 3 Plus Ultimate board. So it's I think also a 4-layer board with which will have a bulk grid array FPGA chip on it, and also some RAM chips with bulk grid array. And Jan and I are very curious if I can solder them manually by heat gun, for example, or in the oven. So if my production street will be up to soldering those, but we'll see. So I got a couple of chips to test on the board. It's only will be hard to actually know if the soldering will be good enough. But I've seen some videos from, for example, Lewis Rossman, how he does how he put some new chips with bulk grid array sockets, if you may call it, packages. So I think we must be able to do it, but it's just a bit hard to make sure that every board will have a perfectly soldered components on them. Okay, R2, R5, where's R5? So I'm not hurrying, as I said, I'm just taking the time. And I will definitely not finish the board today, because I need more parts, other parts, and R10, where's R10? It was R5. So where's R10 then? Oh, that says R10, but where should it be then? R10? Okay. Oh, now I'm confused. Ah, okay, wait. R6. Huh? R6 is a 1206, okay. Okay, but why? Why did I choose a 1206 for that one? Okay, so the labels are not very logically positioned on the board, if I may say. So this is the position for R6, and now I can place R10 here, and let's connect the other side first. We'll put around on 1 mega ohm 1206, that's important. So let's put a question mark as well there. And the next is what did it say? R5 or okay, that will be R12, but I don't have R12, so R12 should be there, and I don't have it. Right. And I'm thinking maybe I should just get correct components anyway, but that would be a waste of this stream, I think. So we'll just continue with the parts I have and finish it later. Right, so I got these 3 parts on, and just found out that R6 is the one up there, and that shouldn't be a 0603 or 0805, it should be a 1206. I have no idea why. There's no, okay, there's a reason for it. That's because it's an eighth of a tenth, sorry, tenth of a no, an eighth of a watt power that it must be able to consume. That's why it is a 1206 part. Don't know why. It's a mega ohm, where a mega ohm that must be able to consume an eighth of a watt. Oh, we love power. Maybe it's for safety something, I don't know. Sorry. Okay. Now the next parts, I have 68 ohms here. Where are those? I haven't seen them. 68 ohms. Where are the 68 ohms then? Where are the 68 ohms? I don't know. I don't see 68 ohms. I don't see missing resistors, so I don't know why I have the 68 ohms here. I have no idea. Maybe we'll find them later on. Anyway. I'm doubting if I should first do the chips, because there's not that much space, and I'm afraid that if I'm going to mount the capacitors first, that I don't have enough space left. So let's start with the chips then. U2 is a W5100. I think those are in these cages here. To check, I'm not sure. I think this is the actual Ethernet chip. Oh, the pins are banned. The WizNet. Pins are banned. I hate that when suppliers ship the chips with, although the packaging should be good enough, but they ship them in a way that the pins are still bent, which is ridiculous. Okay, now I need my magnifying glass to check out if the pins can be bent backwards to the original position. I think it can be done, but it's a bit hard, and I don't think these chips were that cheap, so this is not a very good sign. Anyway, it's a first batch, these things can happen, but next time I will get them from another supplier, maybe. Let's see if the pins are good enough. That's good enough. That's good enough. That's good enough. Maybe I will buy a microscope in the future, because I'm using the magnifying glass quite a lot. So where's pin 1? Must be that one, because this in a corner that's a bit different than the other corners. And I think this chip has more pins than the one I'm used to. I'm not sure. I'm not sure if there's 64 pin or more. It seems that there are more pins on this chip, but anyway, let's solder it on and continue from there. Right? Perfect. Of course, you need good eyes if you want to do things like this manually. Very happy with my good eyes. And you know, I play laser harps from time to time. So some people always say, "Be careful, Ben." But when you're using lasers, you really should know what you're doing. For example, if you use cheap lasers from China, you have to make sure that there's no infrared light coming through the output of the laser that you cannot see, because infrared light will not output to the same angle as the visible light will. When you're using a laser scanner, for example, so you may just put infrared light into your eyes, which is very dangerous, of course. So what I'm always doing is, if I use a cheap Chinese laser, I will check with some camera if there's any infrared light, and if so, then I will put an infrared filter, optical filter, to make sure there's no infrared light leaking out. That's dangerous for your eyes, for example. It's a completely different topic, but it's also ZX Spectrum related, because my laser harp is driven by ZX Spectrum, and even the media output is done by ZX Spectrum, so it's kind of related. I'm not sure if you can connect Spectranet and a laser media interface. I don't think so. Okay, some other things I would have done differently in this board is, for example, the ground planes. There are some pins of this chip here form one big ground plane for the chip, and I don't like that, because it's kind of hard to see if the connections between the pins should be there or not. So I'll definitely be using the magnifying glass again in a second to make sure there are no unwanted connections. And now these two pins are making it hard for me. What's going on there? Might be my flux pin, which is empty. I guess I have to get another one. Let me grab another one. Plenty of those. Oh. And here's another one. I would always do this because I want to make sure there's enough flux on the tip of the new pen. Let's see, what are people saying here? Missing a lot, I think. Loving the blue tech to hold the chip. Blue tech? What's blue tech? Oh, you mean this tip here with the double adhesive tape? It's just a trick. Don't sneeze. Okay. 50-pound diode? My god. Anyway, let's go on. Oh man. My eyes are... today is better, but usually my eyes are just continuously flooding because of the hay fever. But anyway, it's really hard to work with those issues. Let's do a check if the pins are not interconnected when they should not. There are some interconnections here So I need more flux, and I'm going to buy the liquid flux because for these things it's a bit better instead of using these pens. Because the pins were bent a bit, it's a bit harder to make sure everything's correct. It's not my fault, it's the chip, the supplier actually. Not sure where I got this from. I try to buy everything at Farnell these days because they have a lot, but they don't have the old stock parts, for example. And even the Spectranet had some already has some discontinued parts. So sometimes it's hard to obtain these, and you need to use other sources to get them. But this looks very good. There's only one connection that shouldn't be there, so let's try to get it out this way first. I think this will work. This one unwanted place there, which is very hard to get rid of, but I have to, you know. I have to, so it will be hard. I should have something that's smaller than this knife, which I don't have at the moment. I will buy some other knives in the future because the cork came in for creating the coasters, and I'm using if it will work spray glue to mount boards to the cork. But to cut the cork into the correct pieces, I think it would be nice to use a scalpel, for example, instead of this knife. And sometimes there's some metal parts in the solder that will just not get out between the legs of the chip. Because the legs of this chip are very close to each other, it's kind of hard. I'm using some more flux from the pen. It doesn't really work. I am being careful, so I don't want to mess it up. Still getting connection. Let me check if that should just be there. You never know. Nope, that's the wrong board. We'll do it later. Yeah. Oh, it should just be there. Come on, that's ridiculous. Stupid design. Sorry. Okay, I don't think you can see it, but there's just some connections between the pads on the board of the chip, and okay. So I'm just messing it up with no reason, but I think it's good enough. And this happens a lot when you're doing a first board of a series. You have to know all these details. But it's all the pins are connected correctly at the moment, so I think it will be no problem. I think these are for power as well. How can we find out? Well, by measuring. Because I have another board here to find out where the pins will go. I think there are some, because we have 4 layers, there's a ground layer and there's a positive voltage layer. I'm just not sure. Oh, look, that was simple. So this is, I guess, the positive point, and that is the negative one. Or is it all negative? Oh, this is all ground. This is all ground. It's all ground. Ground, 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 ground. Then we have a positive one, which is the positive one. This should be a positive pin. Where is it going? Where is it going? This is the voltage regulator, isn't it? I don't know. Okay, it's coming out of this conductor here. Okay, so I guess this is connected to one of these pins here. No, not yet. I have to check it out. But not now. Okay, not for now. Okay. It's connected perfectly, so it's not a problem at all. So this chip is on. It took some time, which it usually doesn't. But I want to make 100% certain that all the pins are mounted correctly. Okay, so we have put on U2. Now we're going to put on the CPLD chip, which is the biggest one. I have plenty of these. There's also a JTAG connector here, so that's for programming the chip later on. And I do these chips a lot because they're also on the ZXHD interface. These chips are awesome. These can contain quite a lot of logic, and they also can be used to translate voltage levels, for example from 5 volt to 3.3 volt, which is done on the ZXHD. So we're using the CPLD chip to convert the voltage levels and to act as a filter, so the Raspberry Pi and the ZXHD will not get fed by data that it doesn't need. So there's some filtering done inside the CPLD logic. And it's not the most expensive chip as well, so it's a great way of interfacing 3.3 volt stuff to a ZX Spectrum. And there's some other thing that's very cool on the ZXHD, by the way. Maybe it's cool to talk about it. That's the Raspberry Pi has a 3.3 volts voltage generator, which is fed by 5 volts USB power or GPIO 5 volts, which and the 3.3 volt that is generated on the Raspberry Pi is also available on GPIO. So what we do is we feed 5 volts to the Raspberry Pi and use the 3.3 volts to power the CPLD chip, and that works great. So we don't need any voltage regulator on the ZXHD. The Raspberry Pi is very robust and very well engineered piece of system on a chip, which can run a complete operating system for only a couple of euro or pounds, which is very, very cool. And don't try to run Windows 10 on it because that's too slow. There's a Windows 10 release for Raspberry Pi, but anyway, it's way too slow to do that. Okay, this is soldered in one attempt without any problem. Let's go on with the next chip. We have the ROM chip here, and that should be programmable from the ZX Spectrum, which is cool. I guess it's this one, or is this the SRAM? This is the SRAM, and this is the ROM. So I hope you guys think this is cool to watch. Let me know if you do. I would like to know. Okay, there's no pin 1 sign on the board for this chip. That sucks. Okay, so I have to get to my other documentation again and find something like a board layout or maybe a picture from someone else. Let's see. Okay, we have the Gerber files, we have downloads, we have an archive, hardware. Nope, ROMs. It's only for installing. We have a guide that doesn't say anything about assembly, I guess. We have an info.txt. We have an ETH up. Not sure what it is. I guess we have to get to the Gerber files then. Extract to Gerber. Yep. readme.doc. What does that say? Nothing much important here. So I guess I have to open Viewplot then, my tool which I use to view these files with. And let's open one layer. Maybe I can show you in a second. Let's do a screen capture on the left. Okay. It's nothing much you can see here, but I'm trying to load files here, and those should be visible now. But as you can see, I'm trying to solder this chip on, and these are just the tracks on the board. I'm more interested in solder. No, not the solder mask. I want the silk screen information. Silk screen, front silk. This one. Right. Here's the silk screen, but there's no indication of where pin 1 is. I can see something here, but it's not the same as my chip. I hope I have the correct chip, because some of these chips may have completely different pinout if you do not have the correct model. So what I'm going to do now is just Google for the part, try to find out if we have the correct model here. So this is the AM29FO10. And I'm going to open the datasheet here, one of the datasheets, and see if there are several pinouts or only one. And there are several. Oh, I hate that. Okay, there's a reverse pinout and there's a standard pinout. And I think I already selected the correct part, but the strange thing is that I'm not sure how it should be mounted. So I guess it would be easier to get a photo of the Spectranet. Spectrum 104 FM. Hey guys, this is Spectrum 104 AM. FM. AM maybe. If the quality would be worse. Very cool, Steve. You're attending a meeting and you're listening to me. Okay. Hey Draken, good afternoon. Alright, what I will do is try to find a photo of the Spectranet. Do I have photos downloaded already? Let me see, I have an archive folder. What's in that archive folder there? Oh, there's a schematic, which is useful. I can use the schematic, of course. Let's just use the schematic. You can see it here on the screen. This is more useful than user ROM, you know. Okay, so what I want to know is we have a negative, which is pin 24, and we have a positive connected to 5 volts. So I guess I will just have to find out which is pin 24. Well, I think that's the most easy way of going on. Let's try to find pin 24. Alright. Pin 24, which one is that? I guess it only has 24 pins in total. 3, 6, yes, it has 24 pins. So my best guess is that this is pin 24, and that should be ground. No, it's not. Which one is ground? Ah! None of them. I hate it. Now I'm getting afraid, because now I'm worrying if I have the correct ROM chip, and I'm doubting now. So I'm getting back to the datasheet I just looked into. Was it this one? I think so. And where's the pinout? Where is the pinout? Okay, here's the pinout. Alright, pin. Oh, it's a 32 pin. Okay. I'm mistaking, I guess. Is it 32? Yeah, it's 32 pin. Okay, it's 32 pin. It's a relief. So I must find VSS, which is on pin 24. So let's see again if this is the. Oh, okay. This is pin 24. Okay, I think we're good. Let's make sure it is. So pin 32 should be output enable. Where is pin 32 connected to? I don't know which line is that. Doesn't say. It says read. Is it just connected to read? Nah, can be. Maybe it's better for use pin 30, which is chip select here, which goes to the CPLD, I guess. Is this a CPLD? Yes, this is CPLD, and it's pin 70, I guess. Pin 70 will be a bit hard to find, but pin 70 is more easy to find than the CPLD and this ROM chip. So I want to make sure that this pin 30 here is connected to, you cannot see, maybe I should go back to the workbench large. Let me see if we can see the same here. Does it work? Yeah, okay. So what I'm going to check now is if pin 30 here is connected to pin 70 here. So it's a 100 pin CPLD chip, starting here with pin 1. So there are 25 pins on each side, which means that this is pin 24, it's pin 49, no sorry, this is 50 of course, no, 48. Now I'm completely mistaken, I'm messing up, sorry for that. This is 75 of course, pin 75, I just have to count 5 back from there, 75, 4, 3, 2, 1, 0. This should be connected to this, and it is. So now I know the correct orientation of this RAM chip here, so let's solder it on. I'm using my handy dandy piece of tooling here. So it was quite hard to find this ROM type with this package. So that's another reason that I would do a different design, and even I would even select a dual line package instead of a T-sub package, which this one is, because this is hard to get and hard to solder. But anyway, for a machine, of course, it's not, and you can program it from the ZX Spectrum itself. But for if you use a dip chip, then you can program the chip outside the ZX Spectrum, which is a bit more easy, I think. But anyway, it only matters if we can get this board working. This is the main thing we're doing here. And I don't have that much doubts. I just ordered some wrong components, so I have to sort it out. It was just stupid of me, just not checking what I actually need. I just looked at the values, not at the packages on the bill of materials. That's my bad. It's pretty bad. But we'll live. Alright. Let's mount it. Now the other side. Right. There's still a solder joint there. I think we can remove it by just reflowing this. Yep, it's gone. Let me check. Let me show you the results so far. I think you might like it, just because we can focus the camera manually now. So we'll put it in front of the camera and I will start focusing manually. Oh, look at that. Isn't that nice? Look at all the chips. And believe me, the Ethernet chip here, the WISNet chip, is has the big pads with all the ground pins connected together. So that's just what the board looks like. So we are we're throwing the board on the ground. Okay, we're on our way. Now another chip. This is this should have a socket, of course, but I don't have a socket for it. This is the. I hope it's correct. Let me check. I hope it's the part that belongs here. Let's see. Is this U4? Am I correct here? And so we have U3 with that one. U4 is the RDT71024. So this is the SRAM chip. Yeah, I got one that is compatible. But the only thing is that this one actually needs to be in a socket And I don't have the part that will it has the pins that will fit on a board like this, but I've soldered these parts before in this way, so I will just do that. It's not the simplest thing to do, but it will work. And I said, it's just hard to get these parts, and that's because when Dylan designed this board a couple of years ago, the parts were still easy to get, but nowadays some of them are discontinued and it's a bit harder. I must say this goes without issues. I don't see any problem so far. But you can imagine it will take some time, and of course I would love to do this by a big place machine, but that's only interesting when you're doing, I would say hundreds, because my machine will be set up for 0805 parts mainly, and when you have to change all the reels with 0306 and all the software and configuration, that will be time consuming, and you have to test it all over again. Come on, man. So I wish this board only used 0805 parts, and maybe I will just do that. Maybe I will just use 0805 parts if it will work, and the machine will not have any issues with it. Putting it on 0603 pads, and why would we complain? Because it should just work. I don't see any issues with that. Okay, it's not perfect, but if it works and no one can see it from the outside, then it's really no issue. So maybe we will do just that and use 0805 parts. I'm not sure. Okay, that went easy. Let's see if there's anything in the chat. Whoa, a lot. Refocus, winning Wozzy. Nice. I hate buses and diagrams. I find them very confusing. Well, I don't, but when I'm using buses and diagrams, I always label each and every signal that goes from a bus. But anyway, refocus, please. Oh, sorry. Oh my god. Oh man. You guys, you need your glasses on. Now I get what you mean. The problem is I only have two big screens here, and I cannot show everything on it at the same time. Sorry, Iron, and everyone else, but it's good now. I could use some more monitors, but maybe if I make some more profit, then I will just buy 2 more of these, because I could use 4. It would be really useful having 4 of these monitors. These are, I thought, 24 inch or bigger. No, yeah, 24 I think, and quite high resolution. What is the resolution of these? It's 2560 by 1440, so it's just 1440p, which is getting the standard resolution of PC screens in the near future, I guess. Anyway, let me just try putting more on the screen here. I'm trying to, and I also want to be able to follow the chat. So that's what I think. That was a call from someone from a country starting with 39. No, I'm not using a 4K. If you want to use 4K, then you still have to issue that you can only use 4 corners of the screen to put stuff in. So I just want to have 4 of these 1440p screens, and not more than that, because they will use too much power. I don't like that. Okay, next part. This was the SRAM chip. We got it on now. So now we will do the small buffer chips. Where are they? Where should they go? So I have these small buffer chips, but I have no idea where they should go. U5. Oh, this is one of... Which one is this? Let me check. Which one is it? I don't know. What's in here? These are the rum chips. Oh. Am I missing a part now? So I got these parts, but I think these are also the wrong packages. Yeah, they are the wrong packages. I thought about the correct ones, but these are not the correct ones. So I need a 20-pin SWIC package, and these are very small and not correct ones. So just another question mark here then. How can I be so stupid? I haven't checked anything of these. So I cannot solder U5 at the moment. Can I solder U6? What is U6? U6 is another buffer chip, single gate. Oh, it's a small one. Okay. I think I've seen those. So these are not correct. Let's put them away. Where do I see the small ones? Are these the correct ones? Yes. One gate. I like these ones. I use these single gate parts quite a lot because these are so small and they're available in all kinds of functions, which is great. I only need one, I think. Yes, U6. I hope this one is the correct package. I still wonder why I bought parts with the wrong package when all the part numbers are here on the bit of materials. Yes, I feel so stupid. Anyway, let's see. This should be U6. Where's U6? I've seen it before. It's there, over there. It's very small. It's also one of the smallest parts on the board, but I think it will just work because it will. Right. For a second I was hoping someone was actually calling because I put on a new ringtone from Gareth Emery, his latest single. I made it myself. I not made the single of course, but I made the ringtone myself. So an excerpt of the song of course. Anyway, that's on, U6 is on. Then we go to the Mac Jack RJ45, but it's just the RJ45 connector, which is way too big to do now. So let's wait with that. I think we have to go get over to the capacitors. There are quite a lot of capacitors on this board. Really a lot. Let's count how many I should be on in a second. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 of 100 nanofarads. Okay. Oh, okay. So one thing I'm going to write here is that I think for this board it's better to first do the SMD chips. Oh, chips, and then 1, 7 and 2 the SMD parts, discrete parts. I think it's better because the chips are so close to the discrete parts here. Right. I think we have to do the capacitors first, and after that we have to do the transistors. There are a couple of transistors on this board as well. Let's find the correct ones, and I guess I didn't buy them as well because I thought there were only 5 parts on this board. Oh, more of these. Right, let's just do it. 18 of them. So 18. Oh, this is exactly 18. That's a coincidence. Because I have 2 stacks of 10 and one of them has 2 out already. Right, you should get ultra wides. These are quite wide already. Code 39 is Italy. Okay, someone from Italy seemed to call me. Some of you. Antonio, you're great, man. Calling me live during a stream because I was out of focus. You're great. I saw the title and thought we were going to see some pick and place machine action. Yes, that's what I want, but the problem is I didn't have time for that yet. I'm going to start with those streams I think tomorrow. I hope, but I'm not sure because I have to do the, for example, the plus delights and some other interfaces, batches of interfaces tomorrow. That's just life, you know. We'll get to the pick and place, but this is one of the things I've promised for a month now, and I really should Just do it. Right, we have C26, C27, C28, and those are not 100 nanofarads. What on earth? Why are they connected? Oh, okay. Why? 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 It really says C28, 27, and 26. So C27 is a 1 microfarad. C28 is a 4.7 microfarad. And C26, what is C26? It's a 10 nanofarad. But why? How do you, because they're connected at one side. Oh, it could be, of course, no, they're connected on both sides. Why? Is that a way of trying to achieve an exact capacitance? I guess it is. But it's, why did they connect all the pins together? Because it's, Anyway, okay, not the easiest way of doing this. Okay, there's no 100 nanofarad here, so let's just find the first 100 nanofarad. Is 21 a 100 nanofarad? Yeah, it is, and 22 as well, yes. And those are connected as well, so combined these make 200 nanofarads. I guess some of these parts need to be a very specific value, and that's the reason why he combined several capacitors into one bigger one. I have no idea if these values can be obtained in another way. I guess it will be possible, but maybe he chose this because he had these parts laying or something. I don't know. The same with the LEDs, by the way. The LEDs he used on this specific design are LEDs with built-in resistor, and I don't have those, so I have to find a solution for that. And of course, it's not the most problematic way of. Come on, solder. You can just add a resistor yourself, so it's quite easy. But I wouldn't have chosen that solution. I would have just used standard parts, which can be obtained easily, like Dom does with the Harlequin kits. By the way, I must be honest. I hate picking up the telephone. I hate it. It always feels disruptive to me. Okay, C16. Um, I just like to just work, do emails and Facebook and talk to you guys, and even like to chat. But I hate phones. I hate phoning. I hate calling. Anyway, that's just me. I don't hate talking to people, but I just hate picking up the phone. Oh, these parts are so close to each other. So there's definitely some reason of using the pick and place machine for this. We're getting there. I will show you the result when more parts are on. So C25 is another value, it's 4.7. I hope I have those. Yes, I have those, so we'll do that in a second. C23 is 100 nanofarads, okay. C23 and 24 as well. It's coming together piece by piece. But it's kind of hard because it's so small. But I think you can see it's not the first time I'm doing this. And I know more people are doing this. For example, Ricardo Saraiva from Portugal now produces the Mists FPGA, which people in Portugal really love because it's For them it's way easier to obtain an FPGA solution instead of original hardware for ZX Spectrums, for example. So many people seem to prefer FPGAs there. He solders them himself. He bought some equipment for that, and so I think if you would like to start soldering stuff, it's not that hard to just get the equipment and start with it. But of course, I think it's good if you have good eyes, because it's hard to see all the small parts. Come on, man! Solder bridges here. And it's important that the parts are actually soldered well enough. And this one isn't soldered now, so too much solder came off now. Ah, no, there's another soldered bridge. Come on, the parts are so close. Oh, come on. And I don't think these should be connected together, so that's why I'm trying to get enough solder off. Come on. Still solder bridge. And that may be caused by using, of course, incorrect package of these parts. So if I'm going to do them manually, or I'm going to do them by using the pick and place machine in the future. Anyway, I should just use the correct parts with the correct size. Okay, we'll do this in another way. Let's place it a bit to the side. So create some space between the parts, then cool down a bit. And then make sure that they're properly soldered. That's okay. Alright, but I will just get correct parts as well. Alright, next ones. How many are left? About 10. C9 is 100 nanofarads, and these are typically used to make sure there's no distortion on the power supply of the chips. So for higher frequencies, switching frequencies of other parts of the board, for example, could mess up the voltage power supply to the other chips. We typically use 100 nanofarads for those. C2 is not. Oh, it's also one. Okay, indeed. Okay. Alright, I think most parts are on already. We're getting there. Okay, we have C12 and C14, which are 18 picofarads, and also very tiny. And we have C18, which C18 I mean, so instead of which is this one. I should start soldering that from the other side. Otherwise I will not be able to solder that side anymore, because the parts are so close to each other. And now our resistor comes off because of the heat. Right, it's back on again. So this is definitely not something for someone doing it for the first time. Alright, what's left? The other side of C16. I have to check all the other parts later on. So here's another 100 nanofarads. Okay, looks quite nice. Could use some IPA, but we'll see that later on. Our 12, what was our 12 again? Was the missing 12K? Okay, that's for later. We have C6, it's also 100. Okay. And I can measure if all the pins are connected correctly, of course. But I think I will only do that when we find some problems with attempting it to run on a ZX Spectrum. So not now, because I think all the soldering connections are quite okay. As far as I can see, if the solder flows underneath the part, then in my opinion, the connection is good. Okay, C7, no, it's another one. I have 3 100 nanofarad parts left, so I must find where they belong. So let's see, C12, no, C26, 27, those are other parts. 28, C25, nope. C7, I just checked that one. Which one are left? Oh, C17, I found one. That one goes there, maybe on the bottom of the board, maybe, I haven't checked, but parts here, no, fortunately not. So where are the other parts going then? Ah, C11, yes, I found one other. We're almost done with these. And I see, no, it's another one. Just one more, I have one left. So which one is it? Which one is it? C10, it's C10, yes, and C11 as well. And that's strange because I don't have any left, and I hate when that happens. So I have 2 more, I need 2 more here, but I only have 1. That's a pity. Maybe I made a mistake, I don't know. I think I counted 18, so that's odd. Will not worry too much about it now, but I must have made a mistake then. Did I count wrong then, maybe? 5, 10, oh, 18. Ah! Why? What did I do wrong then? But, well, we'll see in a minute. Just add 1 for now. Hey, Patrick. Mr. Boys, yes, Mr. Boys was. Hey, Stuart. Cool. And C11, I think that's the latest 100 nanofarad, but for some reason I needed 1 more when I exactly counted the number of these that I thought I need. Anyway, let's get it on. Okay, so I think we have all the 100 nanofarads, then we'll get the 1 microfarad. I have that as well here. And for that I have the, oh, this is the wrong one. I need 1 microfarad. This one. I need only 1. And that is C27. Where's C27? That's one of the ones that should be connected to the other ones. So the middle. And then we have 28 and 26. What was 26 again? 10 nanofarads. 10 nanofarads. Right. I think I will just do these manually, and when I'm doing a couple, and it will go a lot faster than I'm doing now. But I think I will just get another of those blue cabinets for 0603 parts and do these boards manually. But of course we just have to know if it will work. So I know I have the 1 nanofarad. Which one was that? Was it 10 nanofarad? 10, I think. 10 nanofarad. C26. Was it 10? Yes. C26. I should focus. C26 is this one. Right, almost, yes. So this is one of the 3 that are connected together in parallel. So that's 26, and then we need 28, and it's a 4.7 nanofarad. Sorry, microfarad. Is it? Microfarad is this. So 2 of these. Looks nice. So now I'm connecting the other side, and these are all connected to each other. Alright, looks a bit ridiculous because all the excessive amount of solder, but that's what you get when you're doing it manually. It just has to work. That was 28, now I need to find C25, which is this one here, which is also 4.7 microfarads. Right, will not come off the board anyway. Alright, then we need a, messing up the pen. 10 microfarads, 16 volts, because I think this board needed 12 volts on that part. I've checked it before. Right, so this one, and that is C7. C7, where's C7? There it is, It's very close to some big power part. Should be series power part. Alright, and now we need 150 microfarads, and those are tantalum, and I've got those as well. Those are a bit bigger. Oh, I see. Now I can see why I counted wrongly. There are 19 parts, including C2 here. So these are all 100 nanofarads. So there was no mistake in the 100 nanofarad parts. What are you building? Thomas answered the question. No, nothing on the other side. Dylan also made sure that the board would be could be assembled with a single-sided pick-and-place production line, just like mine, which should still be prepped. So I have 2 of these, and I have no idea what pin 1 should be, so I think I will look up a photo of a Spectranet interface later on. But first I need 2 times 18 picofarads, and I haven't seen those. Which are those? 12 and 13. I don't have them. I don't have those. Why don't I have those? I don't know. Why don't I have 18 picofarads? Why didn't I just order all the parts? Stupid me. I have no idea. So I'm missing 18 picofarads. I hope I didn't order them. Just don't know where they are. But anyway, we need more. We need these, we need these, we need these. Alright, let's go on. Okay, I'm thinking of doing the last parts for now and ordering the correct ones that I'm missing. And in the meantime, finding out some other stuff. Where's L2? Where's that? Oh, wait. Okay, so these are the capacitors, yes, 150 microfarads, but I also have, I was already thinking what parts those were. I also have parts that look the same, but are not actually the same. I think these are the inductors. One are okay, one are okay. Could that be correct? So I have L2, which is 1 microhenry. I think these are those. But since I've not used them before, I want to make sure. So what I'm going to do is just look up the part number from final in a second. Let's see, final, and that is 935, and then 8072. Right, yes, it should say 102K, and I think it actually says that, but it's hard to see inside the package. It's different. It says something else. So what should it say then? I think it's the correct one, but I just want to make sure. Let's see, what should be on the printed on the chip. Dimensions, no, inductance, code. Code. Okay, so 1R0. 1R0. Okay, it's 1.0 microhenry, so this is the correct one, yes. And K says what the tolerance is, which is 10%. Okay, so this is the inductor, so we will solder that on. It's easy. And I'm thinking, Tom, that maybe it's good that I will keep this one and we'll make one for you with the correct parts for one, and also maybe it's good to keep this one because I have one for reference for myself. And I thought I had some photos, but I'm not sure. Let me check, because I need a photo now. I don't see any photos here. So let me just look up a photo, because I have no idea what the orientation should be. Of course I can measure it again, but I just want to see a Spectranet interface. Here I have a photo. It's not that detailed. But can I see the orientation of the... No, that's hard to see. I can see it, I can see it, I can see it. Okay. I know the orientation of these parts now. That's the only thing I wanted. Call this one the smoke test. Yeah, well, I hope it will not smoke. Get on the board, you. I think I need more solder or something. I'm going to order another soldering station, by the way, in the near future, because I want to get what is it called, Hecko or something. that will also do lead-free solder without any problems. That's what I want. Oh, it's not soldered on. Is this part too big? It looks too big. So I will write a note to check if the part may have the wrong package, because on the photos they look smaller. So I think I need other ones. Other package? Question mark. So a lot of things to check, but it's normal. It's not a big problem. The only thing is that, again, if I would design this myself, I would do some things differently. But I actually do not have the source files of the design, so I'm even not sure if Dylan did it in Eagle. Maybe use something else for that, like KeyCut or something. I don't know. I'm not sure if KeyCut is at all. Not really convinced, because these parts seem to be too big for the pads. If these are actually soldered well, but I think they are now. Yeah, they're good. They're good. Oh, all right. What is remaining? The Mac jack. So I just had a Mac jack in my hands. I'm not sure where they are. I had one. Okay, here's one. What else? What else? Is there anything else at the moment? So just the EEPROMs, I think. There should be a voltage regulator. I don't have the voltage regulator. Why do I not have the voltage regulator? Why? Why? It's just from Farnell, Ben. Come on. Why didn't you buy that? Okay. Oh, I need one microhenry. One more microhenry. Give me a microhenry. I really wonder who thought of that name, Henry. Who would it have been? I don't know. Maybe it's someone called Oliver or something. I don't know. I don't know. Just find it cool. The name microhenry. Maybe if your uncle is called Henry and he's not that tall, then you can call him microhenry. Anyway. Okay, we're getting there. So we need to solder some pin headers in there and some transistors. But I want to solder in this Mac jack, because this is the most important part of all, the actual Ethernet socket. Alright. We're almost, we're getting towards 2 hours streaming at the moment. So I think it's not that bad if I call it a day for this one for now. Of course, we can do the H connector, which will be the A quality connectors which are used that can be pulled off with ease, I must say. So you don't need that much force for them. I think these are the good ones. I can also use the other ones I have, which will sit to the spectrum a bit more tightly. But I'm not sure which one are the best. We'll start with this one and we'll check it out. If it's too loose, because the form factor of this interface is wide, maybe it's better to have the ones on that sit more tightly to the spectrum. I don't know. Not sure yet. I only use those for the bigger interfaces, usually the ones that sit more tight. Right. For example, the Plasti Light uses the other connectors. So it's coming together, as you can see. And I don't have that much doubts with the parts I soldered on so far. The only thing is that a couple of these need programming, for example the CPLD chip and the EEPROM chip. The CPLD can be programmed by my programming machine, so it doesn't have to be connected to the ZX Spectrum with that. And ROM will be programmed on the ZX Spectrum itself. I actually don't know if you can use a div-ID interface, or sorry, div-MC interface with the Spectranet to load files. So I have to find that out. Maybe it's possible. I'm not sure if there will be conflict. So that we have to find out as well. Otherwise, we'll just load it from a smartphone or something. It's not the biggest issue. But I have no idea how compatible this interface is. I don't know. We have to find it out. I just need two transistors. I will see if I have them. And I need a crystal. I have that here. Where should I put the crystal in? Oh, okay, I think the crystal is too big. I have the crystals here. 25 megahertz, yes. I think, I'm not sure, but I think that's too big. Otherwise, but maybe it's not true because I can see on the photos of the. I just googled that. Oh, it will just fit fine. It's no problem. It's no problem. Well, I will create some distance because I don't want it to touch the board itself. Right. Oh, this is just perfectly. Right. Most parts are on. Only the voltage regulator is missing. The LEDs must go get on. Some capacitors, one resistor, a couple of pin headers, and the transistors. I'm not sure if I have them. Are they in here? Maybe. I'm checking if I can find them. It should be the BSS84. I've seen that. I've seen that part. Where is that? BSS84P. Am I mistaken? I don't see it in here. So I think. I don't know. Did I order that one or didn't I? Oh, I need to order that as well. I still don't know what I did. Okay. So let me check. Let me get another color here. So we need that one, we need that one, we need those. We need to check the package of the 150 microfarads. We need to buy those. We need to connect the LEDs. We need to connect the button. Is there a button on here? That's one. Yeah, there's a button. Didn't know. And a MI switch. And a MI, sorry. Okay. Well, let's let me show you the results so far. And we'll call it a day then, because my wife is waiting with the dinner. And here we have the board so far. How does it look, guys? What do you think? How does it look? Yeah, I've seen Twitter on the ZX Spectrum. It's cool. I think it looks good. Quality looks fine. Soldering quality looks fine. I'm trying to make it as sharp as I can, but this is what you get. It's an HD camera. It's not a 4K camera. Spectra bet is face. What? Very nice. Oh, thank you guys. Wow. All right. Okay, this is the soldering so far. You've seen it can be done by hand, especially if you have the correct parts, but I have to do it with this for now. Let me switch off the power here. What is remaining to do? Okay, buying parts, that's one. Programming the CPLD, see if that works. Maybe I need another cable for that because I'm not sure if it's the same pinout for the JTAG connector that I have. I have two connectors cables, so maybe one of them will work with that. I have to find a way of programming the EEPROM once it's connected to the ZX Spectrum itself. And of course we have to hope there's nothing wrong with this first board and it will just work without any problem. I will not connect it right now, but I think that's it. And then we have to connect an Ethernet cable. I have plenty of Ethernet cables laying around here. There are two there, spare ones, and one there. It's all connected with hubs and switches here, so that won't be a problem. And then, of course, when the hardware is okay, then the next step is to do something with it. And I think I will contact Tom for that, because Tom will help me with testing the first board. I hope. I hope he wants to. Because he's getting one from me, of course, just for testing and development. So everyone will benefit from that. I think the board looks really fine. I think I chose the black board. I can show you that actually Dylan chose different colors. He has blue ones, red ones, green ones. Maybe in the future I will redesign the board if I can. If I would take the time to redesign, or just completely redraw the schematic in my Eagle software, maybe I can do that. We'll see. Cool. Thank you, Tom. Thank you very much for that. We didn't know each other when I was starting with this project, because I think it was over a year ago when I first contacted Dylan with the question if he was producing more, and if not, if I could do that for him. So we're a lot of time has passed in between, and now let's continue with it. But there are so many new products coming. So the completely new DivMC Pro series is coming up. The +3 PSU is coming up, +2 and +3 for PSU. What else? I'm forgetting plenty of things. I'm forgetting all things. And of course the MB. Let me just click on this button here. The MB3 Ultimate, which this is. I cannot reach so far. This is one of the first boards of that, and that will be a completely different story. I'm helping out Jen Kusira. Tomorrow I will do a live stream with opening this envelope here, which also is from Jen. And really this is very cool. I should have thrown away the envelope. Let me just grab it. Can I still find it? Oh, I think it's in here. Nope, that's not the one. Oh, where did I put it? Because it's very cool. I think it's... Oh, here it is. Okay, let me show you. Isn't this the coolest? So his company logo, the 8-bit company. Oh, maybe I shouldn't show everything here. Sorry, Jen, if I did something wrong. My address is not a secret, but I'm not sure if the 8-bit company is. Anyway, I hope I didn't create any problems now. But I think the 8-bit company has his address on the website as well. It's from the Czech Republic, and that will be a completely different story. We'll see. I'm going to get up first, and then get down to my family, have dinner, and continue work later in the evening, because maybe I will do the Plus Delight interfaces this evening. We'll see. Okay, guys, thank you for watching. Thank you for spending the time with me. I enjoyed the chat, and we're almost only 6 hours away from 4,000 watching hours from all of you guys annually, which means that I think tomorrow we reached the 4,000 watching hours, which means I can finally monetize these videos again, which I would really like to, because for me it's an extra motivation of making more of these videos. So that will be another celebration, thing to celebrate, of course. I still have to do a ZXHD giveaway for the, what was it, 1,000 subscriber, I think. I have to do that, and then in the meantime we have reached 1,200 subscribers. So let me just quit the stream with this, and we'll see you in the next one. Bye!